Good morning, ladies and gentlemen. Sorry I didn't do this yesterday, but I just ran out of time. So we are going to start off once again with just one more example of how you solve a system of equations. And we are going to use combination elimination. That means we are going to combine the two and something must cancel. So problem number 1. And we should go ahead and put our date as 3, 6, 12. I can't believe it. So we have 2x plus y equals -4, and 5x plus 3y equals -6. Now, Montana wanted me to give him a shout out. So Montana, I hope that you are paying attention right now. We want to combine these two. But if I combine them right now, I get 7x and 4y. That doesn't work. It doesn't help. So that means I'm going to have to multiply. In order to get something to cancel out, I'm going to have to multiply so that I have like a 2x, but I need a -2x here. So that's not going to work. Looking at my y's, if I have a 3y and a y, the opposite of 3y is -3y. So I'm going that route. I'm going to be lazy. I could multiply my x's and multiply both of them so that I got a positive 10x and a negative 10x, but why not just use the y's so that you can only have to multiply one of the equations? It's less room for error. -3x times 2x actually gives me -6x. -3 times y gives me -3y. And -3 times -4 gives me a positive 12. I take my second equation over, because we don't have to multiply it. I still have a positive 3y, which is going to give me an equation which cancels when I combined. We combine the two, add them up. Here we go. And we want something to eliminate. Our y's eliminate. After they eliminate, -6x plus 5x is -1x, equal to 12 minus 6, or 12 plus -6, which is 6. You divide both sides by -1, and you're going to get x equal to -6. I'm not done. I only have the x, and I need a y coordinate for my final answer up here. So what I'm going to do is use one of these equations. I always go for the easy one. One with the least number of negatives or the least number of coefficients. 2 times -6 plus y equals -4. 2 times -6 is -12 plus y equals -4. And when you add 12 to both sides, then you get y equal to 8. So there's my other coordinate. -6, 8. We always combine the two to get something to eliminate. That's combination elimination. Now, we have a couple more problems that we need to look at. Now we have another problem. Sorry, I wrote it down wrong a second ago, so I just am going to start over. Problem number 2 is going to be 3x plus 2y equals 12, and 3x plus 2y equals 6. If we add them together right now for our combination, nothing cancels. We add them and we get 3x plus 3x is 6x, and 2y plus 2y is 4y. So, not going to happen. We have to get something to cancel, but this one actually isn't that bad, because if you think about it, you can multiply by -1. Now, I'm going to multiply the bottom by -1. I don't know why I do that, but some of you may be asking, Miss Baker, I want to multiply the top by -1. Well, that's okay. You can multiply your top by -1. And when I multiply the bottom by -1, I get -3x minus 2y equals -6. When we combine like we're supposed to, now do we have something that eliminates? Combination, elimination. Well, what I wanted was 3x minus 3x to eliminate. That's great. But this one's different. 2y minus 2y also eliminates. So we have 0 equals 6. 0 does not equal 6. This is impossible. 0 cannot equal 6. This is not good. So what happens? I hope some of you are out there screaming it, just so excited. No solution. This is possible. No solution happens when we have two lines which are parallel. So if we go back to our original lines, 3x plus 2y equals 12, and 3x plus 2y equals 6, and we solve for slope-intercept form by subtracting our 3x, 2y equals -3x plus 12, and then dividing by 2, we see that the slope of the first line is -3x over 2, or just -3/2 is the slope. And if we do the same thing over here, guess what happens? These two lines are parallel. 2 divided by 2. The only difference is they have a different y-intercept, which obviously makes them not intersect. So looking right here, parallel lines, no solution. So it is possible to get a no solution with combination elimination. It's going to give you something that makes no sense, a statement that makes no sense. So beware, that is a possibility. Another possibility that we have is x plus y. This is problem number 3. I should have started with that. X plus y equals 8. And 3x plus 3y equals 24. We want to combine, but when we combine right now, nothing eliminates. The whole word, combination, elimination, we don't have anything eliminating. So that means we've got to multiply. I'm going to multiply my top equation by -3. Because if I have a 3x, the opposite is -3x. So that gives me -3x. This is going to turn into -3x minus 3y equals -24. And I'm sure some of you are already seeing that our other equation is positive 3x plus 3y equals 24. So what's happening here? When we combined our two equations, adding them together, everything eliminates. And so we get 0 equals 0. If everything eliminates and you get 0 equals 0, or a true statement, then this is many solutions. Remember when we talked about how if they are the exact same line when you graph them, that it would be many solutions? And so what we're going to do is look at these two lines really quickly. And we have x plus y equals 8. When you subtract x from both sides, y equals negative x plus 8. And when you have 3x plus 3y equals 24, you subtract 3x, you get 3y equals negative 3x plus 24. Divide by 3, and you get y equal to negative x plus 8. So you can see right here, exact same line, many solutions. I expect you to understand combination elimination. I know that this throws in a couple kinks, but it's not going to happen very often. Probably 95% of your problems are going to intersect in one coordinate. Like we did here. But you need to make sure that you understand the 3 different ways to solve a system of equations. I hope you have your notes done, and we will be practicing some problems in class on Wednesday and Thursday, and we will be having a test on Friday for systems of equations. If you are interested in getting some extra practice, it is always a good thing to practice problems and check your answers in the back of the book. All of your answers are available to you because you should have a hard copy of the book at home. And so a possible place to start practicing for your test is pages 389 through right now 390. You all should be able to do any of the problems in the 6-1 review section, the 6-2 review section, and the 6-3, and actually 6-4. So if you want to be an all-star, you want to impress me, then check out some of those problems while you have your day off. Enjoy your day off, and I'll see you tomorrow.